Question 4, I think primarily just kind of gives us an opportunity to practice reading, understanding a diagram, a bit of vocabulary, and then we are also going to find the two acute angles um, in a right. What is a right triangle, right? Assuming that this is not the Leaning Tower of Pisa, it's just a regular wall that's erected at a 90-degree angle to the earth. So a 20-foot ladder is leaning on the side of a building 18 feet up the wall. So how I interpret that, and my diagram indicates it, is that the ladder is 20 feet long, and that means I'm talking about from here all the way to here. So that's out of the way. And we're leaning this ladder up against a wall that, in such a way, well, it's reaching up 18 feet, right? The building or the wall is a little taller than that, but we're going 18 feet. So this length that I'm highlighting in green is 18 feet. And we're asked to find two things, right? We're asked to find x, and then we're also asked to find these two acute angles, theta and beta. Well, the nice thing about x, of course, is this is just a Pythagorean theorem problem, right? So we can, I think that was the first, x is actually the last one, but let's do it first. So I will go ahead and, well, because x is one of the legs of the right triangle, right? Our equation looks like x squared plus 18 squared. Again, that's a leg squared plus the other leg squared. And I know these are legs because they're coming out of the right angle. So here's a leg and here's the other leg. So leg squared plus the other leg squared is equal the hypotenuse squared, which is 20. So I'm going to take away 18 squared from each side. So x squared equals 20 squared. Whoops, this is squared, 20 squared minus 18 squared. And then um, because we're just dealing with the positive roots here, it's the length of a distance. I don't need to think about the negative roots. So I can just write that x is the square root of 20 squared minus 18 squared. So again, let's grab our calculator. I'll pull up the square root template. Whoops, not matrices. The square root template, and I'll just go ahead and hit 20 squared and then minus 18 squared. So I'm looking at the square root of 20 squared minus 18 squared, and when I do that, I get 8.7. Now, I'm trying to think what they asked us to do. Well, let me write this down. So x is approximately 8.7. So let's look at what they asked us to round our answers to. Did it say? Does not say. So I'm going to do this because my values were given as whole numbers. Um, now I'm not going to do. I'm just going to record it as one decimal place. So I'll record this 8.7. So this is 8.7 feet. Okay. So that distance x is 8.7 feet. Now we've got to figure out our two angles, right? So let's see. I guess let's go with beta first. So in angle beta, if I look at this diagram a little closer, so we're sitting up here, and this is this angle this time. And actually, let me go ahead and erase the green here, and I want to highlight this angle with this purple. So here's theta, and this is this angle. So for beta, I've got the adjacent side, ADJ, right? It's adjacent to beta, and this is the hypotenuse. In fact, that's going to be the hypotenuse for both parts of this problem, but I've got the adjacent side right there. So adjacent and hypotenuse is going to be the cosine ratio. So I'll write down here the cosine of beta is equal to adjacent 18 over the 20. And if I take the inverse cosine of both sides, beta is the inverse cosine of 18 over 20. And I can reduce that ratio too, but I'll go ahead and leave it there. So this should be pretty straightforward. I'm getting good at the calculator here. Second inverse cosine, and then it's just 18 divided by 20. And when I do that, I get 25.8. So beta is approximately, I should say approximately 25.8 units. Okay, so let's do the same thing for theta, and I'll do it in this purple color. So for theta, you can see that I've got the adjacent side, ADJ is here, but I don't have any information about that. The opposite side I'm given the opposite side was 18. So you can see for beta, the 18 was the adjacent side, but for theta, it's the opposite side. So here it's opposite now for the second part. For both of these, it is the hypotenuse is 20. So now I'm not looking at the cosine, but I'm looking at the sine because I've got opposite over hypotenuse. So the equation I'm going to write this time is the cosine of theta equals opposite, which is 18. I'm sorry, cosine, adjacent, no, sine. So sine is opposite over hypotenuse. I said sine, and then I'm writing the cosine down here. The sine of theta is the length of the opposite side. Opposite is 18 over the hypotenuse, which is 20. So you can see these are very similar, right? I'm just flipping from sine to cosine. Again, I'll take the inverse sine of each side. When I do that on the left-hand side, I'm given theta. And then on the right-hand side, I'm given the sine of this ratio of 18 over 20. So theta should be approximately, and let's go ahead and grab our calculator here. So again, I'm looking this time at the inverse sine of 18 over 20. And I've got that theta is 64.2. So I'll write 64.2. Now, one thing that you may have noticed, I hope you noticed, is that in this right triangle, of course, the triangle angle sum theorem tells us that all three angles have to add up to 180 degrees. And I already have this right angle that's measuring 90 degrees, right? So the other two acute angles also have to add up to 90. In other words, they have to be complementary angles. And sure enough, if I was to go ahead and grab this top angle, 25.8, and add that to the second angle I found, which is the 64.15, all of that, when I add them together, I do get 90 degrees, right? And even if I round or added their decimal approximate, their rounded versions down here, the 25.8 and 64.2, I get the same thing. But with the calculator, I can use all the decimals it was giving me pretty easily. So that's a nice confirmation that these are the correct angles because they do have to be complements, and they are. They are adding up to 90 degrees. So I can go ahead and write those down, right? Beta was 25.8, and that was degrees. And theta was 64.2, so 64.2 degrees.